As promised in the earlier video, we are going to derive the relationship between the coefficients of a quadratic equation and its roots. So say that the roots of this given quadratic is alpha and beta, maybe, where alpha and beta are any two real numbers. So say that they are roots, and where by roots what do we mean? Like we saw in the previous video, we mean that if we substitute alpha in the place of x into our equation, it will satisfy the equation, that is a alpha squared plus b alpha plus c should have been equal to 0. Only then we can say that alpha is a root, and it same holds for beta too, beta also. And in the previous video we just derived this relationship between coefficients and roots for a quadratic equation that did not have an a term, that is the x square term. The x square coefficient was just 1. So in this video we have an a term, and a is a real number. So a is a real number, and a cannot be equal to 0, because if it were, then this would become a linear polynomial. So we say that a is not equal to 0. I am specifying it because I am going to use this property of a very shortly. So now we have a new problem of finding out the relationship between coefficients and the roots, and we already have an old problem where we saw x squared plus some lx plus m equal to 0, and maybe h and k are the roots. So I am just using different names for different variables here, just to distinguish between the two. So if h and k are the roots, we established in our previous video that h plus k was equal to minus l, the negative of the middle term coefficient, and h times k was equal to m. So this we had established. Hopefully you watched that. And in this video we'd like to establish something of this sort, but we have all three coefficients now. So maybe I should try to reduce it to 2 coefficients, because I know a result for that. So I can divide the equation on both the sides by the same quantity, and I choose a square, the quantity a to do it. So what I mean is ax squared plus bx plus c equal to 0 can be divided on both sides by a. And I can do this only because a is not equal to 0. If a were equal to 0, the division would not be defined. So dividing LHS by a would mean I'm dividing this whole thing by a, and 0 by a is just 0. So when I divide 3 terms by a and all the terms are added to each other, it's the same as dividing each of the terms by a and then adding. So this is b by a, x plus c by a, and this is 0. So which means x squared plus b by a x plus c by a is equal to 0. So this equation, this green equation on top, is the same as this green equation I have written finally. So lucky for us, we have reduced the problem to just 2 coefficients now, and we know the answer for we know the relationship between roots and the coefficients already for 2. So maybe we can apply this here. So the sum of roots has to be equal to negative of the middle term coefficient, and product of the root has to be equal to the constant term. So the sum of the root, so now we have alpha and beta as roots, should be equal to minus b by a, the negative of the middle term coefficient, and alpha beta, the product of the roots, has to be equal to c by a. And this is what we usually see in books as the relationship between roots and coefficients. So I hope you understood. Thank you.